Done on Schoology and on the course information cards. I just want to remind you, that's 5 questions, maybe six. Due Friday. So put a little reminder here. Don't forget the course info quiz on Schoology. Do that. got your date on your well work, the standard. Give an equation or graph that defines a function. Determine the function type. We're doing function families. You wrote down the definition. Function families, functions that share the same characteristic. The parent is the most basic function. All of the other ones are transformations. You can move the function up, down, left, or right. You can flip it, stretch it, shrink it. Okay? So we're going to cover 4 function families on this handout. I'm going to give you this will be a reference for the whole section. We'll refer to this handout quite a bit, so don't lose it. Alright, so right at the top it says function family handout. There's 4 function families I'm going to give to you right here in this handout. The first one's called constant. It's the worst. I don't almost ever cover it, but it shows up in your book from time to time. So the constant function. Then you have the linear function we talked about. Who else has a blank side? I do that all the time in first period. Thanks for letting me know. I do that. So the second function family is linear. We talked about that yesterday. Slope, y equals mx plus b. The third is the absolute value function family, and the fourth is the quadratic function family. So if you can see, there's all 4 of these are in these boxes here. I'm going to erase all of this, so it's a big surprise. If you have a highlighter, you can highlight like I am. All right, so our very first one called the constant family is a flat undefined line. Undefined, no slope. So the parent function is y equals 1, but it could be any number. It could be y equals 4, y equals 10. There's no x value. So this line has no slope, okay? Slope usually shows up in front of x. So I'm going to make this same table in every box. I'm going to put in -2, -1, 0, 1, 2. This is going to go in all 4 tables, these x values. And it doesn't matter for the constant what x is. Y is always 1. So I'm just going to put in a 1, 1, 1, 1, 1. In the line y equals 1 has these ordered pairs. -2, 1, -1, 1, 0, 1, 2, 1. It's just this flat line right there. And it could show up, if it was like y equals 6, maybe it's up here. If it's y equals -2000, maybe it's way down low. The point is it's a no slope line. I don't talk about it a whole lot because it's uninteresting. The domain is a set of x values true for a function. So the domain of this particular function is all real numbers. This is a hashtag. And the range is a set of all y values true for a function. And the range for this guy is just y equals 1. Y isn't anything other than 1 for this whole function. But if we had done like our equation was y equals 8 and we graphed it at 8, our range would be y equals 8. All right, moving right along. Linear. Let's get a dark purple here. So this equation is y equals x. Putting an x here is drastically different than putting a number. Y equals x. I'm going to go ahead and give you guys this info. So the slope is an invisible 1. There's like an invisible 1 over here, making the rise over 1. Up 1, over 1. Up 1, over 1. Do you remember that? Same table. We have -2, -1, 0, 1, 2, and the x values. So I can push this now. So because the equation literally says y is the same as x, y equals x. When x is -2, y is -2. When x is -1, y is -1. So these ordered pairs are a little more interesting. All right, I'm going to plot this point, -2, -2, get my dot down. This is an ordered pair, -1, -1, get my dot down. 0, 0, right at the origin. Reviewing ordered pairs with you while we do this. Plotting x and y. Connect your dots. And this is a straight line, just like someone in this class yesterday said during bell work, a linear function makes a straight line. This line's more interesting because it has a slope. This one's always flat. So the domain of this one, you guys know from geometry, there's arrows on both sides. This guy's going on forever. The domain is all real numbers. The range is going up and down forever, so it's going to hit every y value. So the range is also all real numbers. We're doing good. I'd like to show you a more advanced way to write all real numbers. The line goes to infinity. It goes up to infinity. It goes down to infinity. So what you'll see in like higher math, instead of writing the words, like the higher you get in math, the less they want words and the more they want symbols. So instead of all real numbers, I'm going to do infinity sign. So this means the domain goes all the way from negative infinity right up through infinity. And this is accepted around the world. Around the world, mathematicians know the infinity symbol. Whereas if we write this in English, our math isn't translating around the world. So the symbols are a little more advanced. Sit down. Get back there. So let's put that fancy infinity here for the range as well. Okay, those are our first two old news. Let's put that absolute value. Is everybody okay? I did that kind of quicker than planned because I had to step out. You guys have to speak up because I do it quick. You're like, slow down. No, lady. Okay, absolute value. So this equation is very much just like this one, really basic, no fancy numbers, no negative signs, but see blue. We're gonna do, instead of y equals x, we're gonna do y is the absolute value of x, because it's an absolute value function family. So all of these functions in this function family make a V shape instead of a plain straight line. So they're a little bit more interesting. They make a V shape. So same table, -2, -1, 0, 1, 2. So and then I have this is the real professional lesson. This is just info to help you use the vocabulary correctly. Alright, so now that we have absolute value bars in our equation, we have to put our x values, like we're plugging these x values into this equation, right? So now this x is going inside the bars. So I'm going to show my work a little bit here. The absolute value of -2 is a positive 2, right? Because absolute value talks about distance. So this ordered pair is -2, positive 2. Instead of like the last one we did, which was -2, -2. So this point is up here in the positive portion of the graph. We got the absolute value of -1, absolute value of 0, and then the absolute value of positive 1 is still positive 1. Absolute value is not opposite, it's just distance. So, the bars just make everything positive. And that's what creates the V shape, is it's positive, 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 takes 0, does not enter into the negative zone, bounces up from 0 and stays positive again. We'll go ahead and connect these dots. So every time you see a sharp V shape and you're asked, what function family is this? Even if you don't see an equation or symbols, you say that's absolute value function family. Okay. Domain is same. All real numbers. We're going to hit all the way from -infinity up to infinity. Range is limited. Anybody feeling confident they can explain range? I can see some of you like, Vincent, you think you could do range here? Would it be y greater than equal to 0? Right. Okay, so y never went negative here. So y is going to be everything greater than 0. So we can show that with words. We can show it like this. Our range is numbers using the inequality symbol. That's weak. Or the fancy symbol way is to do 0, comma, infinity. So I put a bracket because it could equal 0. I put my infinity. The infinity sign always gets the parenthesis. Now, let me see if I can challenge somebody in the room. Let's say right now I perform a vertical translation and I shift this thing, let's shift it down 4, right? It looks like that. Would this shift up and down, would that affect the domain or the range? You call it out, just guess. It's going to affect the range only. The x values are the same. It's going to go out left forever, y out right forever. However, the range is different now. It actually does go below 0. So for this green vertical translation, what would the range be? Y greater than or equal to, yeah, it's -4, but yeah. So as this shifts up and down, that's going to affect that domain and range. Okay. So what you're seeing on this handout is all of the functions right in the middle, the most basic functions, but we're moving towards moving them around up and down, left and right, and identifying important things about them after they've been moved. And we're going to make them skinnier, wider. Last one, the quadratic. That's your y equals x squared. So every time x has a power of 2, it belongs in the quadratic function family. If x is all by itself, there's no exponent, there's no bars, it's just numbers, you call it linear. If there's bars, you call it absolute value. If there's a 2, an exponent, you call it quadratic. Same table. So this time we're plugging these y values into y equals x squared. So I'm going to chill for a minute and let you guys do the table this time. This is the most difficult one. So go ahead and fill the table out. You might make a mistake, that's okay. That mistake making is part of the learning process. If you don't make mistakes, you're not going to learn it as well. For anybody that came in late, I think there's 3 of you. If you have your health card or your course signature, you can turn it over. You all good? Thank you. Alright, first period. So this means I have to plug -2 in and square it. I'm going to be careful and use parentheses. Without the parentheses, you might end up just squaring 2. -1 squared. So I'm putting this number right into this equation. I'm taking x out, putting the number in, which means I have to apply this exponent. 0 squared, 1 squared, 2 squared. Alright, what'd y'all get for 2 squared? What'd y'all get for 1 squared? What'd y'all get for 0 squared? Here's the 1. What'd you get for -1 squared? +1 stays positive. What's -2 times -2? +4 stays positive. So our ordered pairs leave us with positive y values. So we're at -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. These get connected with a curve. This is a parabola. See what I just did? I'm going to try better. This looks too pointy. I want it to be curved. I don't want it to get mixed up with absolute value. So sometimes I even with my pencil kind of overemphasize the curve because I just, it's not pointy. Curvy. All right. Another all real numbers. There are functions where the domains aren't all real numbers, just so you know. This one just happens to be all the same, but it does get more interesting. So I'm going to do my symbols. And the range is not all real numbers. This range is more similar to the absolute value function family because it doesn't go negative. So I'm going to go with y greater than 0 again. So try not to lose this paper. There are several concepts in chapter 1. So I think the chapter 1 test date is in like 15 school days, which is approximately 3 school weeks. So in 3 weeks you will have learned so much stuff that you will forget this. So it's really important you keep this as a resource when it comes time to study. Okay, don't lose it. Even though you might not have your binder yet and all that. Okay. Your assignment is 1 through 6 on the back. So when you're ready, flip this over. And we have to talk about how to identify changes. Before I do anything, I guess I can at least read the directions. I feel like I'm going too fast again. The directions read, identify the function family to which f belongs. Compare the graph of f to the graph of its parent function. So why don't you right now, before we compare anything, just name the graph. So 1 through, try to do all 6. You're just doing 1 through 6. All 6, just name it. Say, is it constant, linear, absolute value, or quadratic? And please feel free to talk about it. You don't have to do it in silence.